Welcome to the January 2019 edition of the AJP-Heart and Circulatory Physiology video table of contents, or from the editor's desk. Irv has asked me, Harry the Turtle, to stand in this January. I'm a little nervous, but I assure you that my heart rate is very low. As the new year dawns, so does more outstanding cardiovascular science from AJP. I want you to all know that the journal had a good 2018 with an increase in submissions. New policies implemented by the American Journal of Physiology have gone into effect. We expect 2019 to be even better. I know you're anxious to see a smattering of this month's issue, so here's a glimpse. In an excellent review by Jamayar et al., the role of coronary collateral growth is discussed. Ischemic heart diseases cause millions of deaths around the world annually. While surgical and pharmacological interventions are commonly used to treat patients with ischemic heart disease, their efficacy varies from patient to patient and is limited by the severity of the disease. One promising approach for treating ischemic heart disease is induction of collateral coronary growth. In this review, the authors describe the growth of coronary collaterals, the various factors that contribute to coronary collateral growth, the animal models used to stimulate coronary collateral growth, and the cardioprotective effects of coronary collaterals during ischemia. Dalek et al. Examined the role of IL-13 in promoting neonatal cardiomyocyte cell cycle activity and cardiac regeneration in vivo, and investigated the signal pathways downstream of IL-13, specifically in cardiomyocytes. Compared to control, cardiomyocytes from neonatal IL-13 knockout mice showed decreased proliferative markers and coincident upregulation of the hypertrophic marker BNP and increased cardiomyocyte nuclear size. Following apical resection in anesthetized newborn mice, heart regeneration was significantly impaired in IL-13 knockout mice compared to wild type. Administration of recombinant IL-13 reversed these phenotypes by increasing cardiomyocyte proliferation markers and decreasing BNP expression. RNA-seq on primary neonatal cardiomyocytes treated with IL-13 revealed activation of gene networks regulated by ERK1/2 and AKT. Kin and co-workers studied the role of galactin-3 in a mouse dilated cardiomyopathy model with transgenic overexpression of mammalian sterol 20-like kinase 1, or MST1. MST1 transgenic mice at 3 to 8 months of age exhibited upregulation of galactin-3 by about 40-fold. Transgenic mice had dilation of cardiac chambers, suppressed left ventricular ejection fraction, poor LV contractility, and relaxation, a 3-fold increase in LV collagen content, and upregulated fibrotic genes. Galactin-3 deletion in MST transgenic mice attenuated chamber dilation, organ congestion, and fibrogenesis. RNA sequencing identified profound disturbances by MST1 overexpression in the cardiac transcriptome, which largely remains in the transgenic knockout hearts. The authors conclude that cardiac MST1 activation leads to marked galactin-3 upregulation and transcriptome disturbances in the heart. Galactin-3 deficiency attenuated cardiac remodeling and fibrotic signaling. ATP and norepinephrine are co-released from peripheral sympathetic nerve terminals. Calcoran et al. Determined if these are stored in the same vesicles. They conducted an immunohistochemical study of vesicular monoamine transporter 2, VMAT, and vesicular nuclear translocase, VNUT, as markers of vesicular containing norepinephrine and ATP in sympathetic nerves of the rat tail artery. A large fraction of varicosities exhibited neighboring rather than overlapping VNUT and VMAT fluorescent puncta. VMAT, but not VNUT, co-localized with synaptogamin 1. These transporters overlapped with several isoforms of calcium channels. With the use of wire myography, inhibition of field-stimulated vasoconstriction with the CAV 2.3 blocker SNX482 mimicked the effects of the P2X inhibitor suramin, rather than the alpha adrenergic inhibitor phentolamine. They conclude that the majority of ATP and norepinephrine stores localize to separate vesicular pools that use different synaptogamin isoforms that localize near different CAV2 isoforms to mediate vesicular release. In a rapid report, Park et al. Evaluated the effects of continuous laminar shear stress on endothelial autophagy in humans. Primary endothelial cells were collected from the radial artery of 7 men before and after 60 minutes of rhythmic hand grip exercise performed with the same arm. Immunofluorescent antibodies were used to assess indices of autophagy, nitric oxide generation, and superoxide anion production. Hand grip elevated arterial shear rate about threefold. Compared with values obtained from endothelial cells pre-hand grip, post-hand grip endothelial cells increased expression of phosphorylated eNOS, NO, superoxide, Beclin-1, microtubule-associated proteins 1A and 1B, autophagy-related gene, and lysosomal-associated membrane protein 2A, and decreased expression of the adapter protein P62 sequestome 1. These novel findings provide evidence that elevated arterial shear stress associated with functional hyperemia initiates autophagy, activates NO, and increases superoxide generation in primary human endothelial cells. Thank you for watching this month's issue. Remember, our editorial staff is here to help you publish your best work, so call on us anytime with questions you might have concerning the suitability of your work for our journal. We'll get back to you very quickly. Remember to read and cite our guidelines papers and look for new guidelines papers this coming year. Finally, we remind you that 2 of our calls for papers are expiring at the end of the month: Adaptive Immunity in the Cardiovascular System and Many Avenues to Cell Death. We wish you every success in the coming year, and don't forget to send us your best work now.